these faces.
Are there any aliens on the moon, Daniel?
I can't say anything about this. You
Daniel,
will read about it very soon.
you can't or you won't.
At the moment, there are none, but there might be soon.
Okay.
A bunch of techno signatures, but those are all ours. So far, at least.
No, but that's an excellent answer to drive traffic.
It is.
Blog.
That's right. Good point, James. Oh, well, we still have people wandering into the room, which is just fine. Feels like a conference room and people are slowly coming in and finding their seats.
Jonathan, do you want me to drive? I can.
Yeah,
drive.
why don't you drive the deck? I'll introduce you, James, and we'll get started. It's 10:02, so why don't we go ahead and get things kicked off today? Again, thank you all for joining us today. Today is really for you. We want this to be a place where you can learn a little bit about what the FDL network is, what the Lunarlab.ai initiative is all about, and hopefully be enthused enough to want to pursue connecting and being part of this network of approximately 800 scientists from around the world who are doing truly meaningful work at the intersection of space and AI. So without delaying any further, I would like to introduce my good friend and colleague. He's really the founder of Frontier Development Lab, which is in its 10th year now, if you will. James Parr, please kick us off and tell us a little bit about the FDL network and what we're doing this year with Lunarlab.
Thanks, Jonathan. I sort of realize now this headline, I'm not sure where it came from, but obviously it's going to be, whatever we pursue is going to be a little bit sharper defined than that. And I'm happy to see Ben and the gang here to help us sort of talk it through. But obviously we really want to support our colleagues at NASA and Luxembourg Space Agency at ESA return to the moon in the next few years, and that's one of our motivating aspirations. So what's the specific thing that we are interested in helping with? And this is a little sort of mock-up that we did, and there's actually a sort of a richer animation which I'd like to show you, and with a huge caveat that is eye candy, and probably the lunar scientists amongst you will kind of wince a little bit because it's sort of a future-facing exploration of kind of potentially understanding the debris on the lunar surface. But we thought, hey, we'll try and visualize something anyway, just to imagine what the future could be like. And I'll show you that in a little bit. But really, the goal this year is to build on our excellent portfolio, and we're so proud of the portfolio of capabilities that we built with FDL for the moon over the last 5 or 6 years. And we didn't actually do anything on the moon last year. And this was giving me particular anxiety because we'd had such good momentum. But this year we want to get back to it. And our friends at Luxembourg are very keen to support that as well. So we're sort of steaming forward with good intention. I know Ben's got to leave soon, so I thought I'd jump in very quickly on the sort of overview of this discussion, and then we'll change gears and talk about the potential challenge. We'll do introductions, and again, if you know us and you've been with us before, we just invite you to put something in the chat, say hi. What's your favorite sci-fi plot twist is the thing we're asking this. It was what's your favorite sci-fi shoot yesterday, but today it's favorite plot twist. We'll as I said, we'll go into the challenge area that we're kind of dancing around this year. And then if you haven't been part of FDL before, we'll spend the second half once Ben drops off talking about how FDL works. But really sort of just diving in, I wanted to introduce Ben Moseley, who's been really one of our, I know he's very modest guy. I don't want to embarrass him, but certainly we wouldn't have had nearly the sort of impact we've had with the application of physics-informed methods without Ben. He's really led that for us, and we're extremely grateful for him introducing that kind of those methodologies to us back in 2019. And it really was, it was a great thing because it meant that we were right at the sharp end of application of pins to scientific applications. And he's now a professor at Imperial, and so we're so proud of where you've kind of gone and the work that you've done for us over the years. And it's great you're here. And I'm not sure if Valentin can join, but Valentin's been helping sort of probe and prod this idea that's emerging. And really, this came from John Stock. I was on a call with John Stock, who's, if you don't know John, previously at Innovation Director at USGS. He's now on detail at NASA Ames. And he said, you guys have to revisit the stuff you did from 2019 because there's lots of goodness in there. And so really, that's really the starting point in terms of our discussion today. As I say, please do introduce yourself in the chat and we'll sort of get the conversation going. But really just to say, okay, what's the sort of thing that we could do, which is revisiting the work of 5 years ago. Is it 5 years? Golly. But now with everything we know about foundation models, to see if we can really build some sort of useful tool for surface model feature detection. And I know there's a lot of people on this call who know this much more detail than I do. But the one thing perhaps I will say is that FDL's, we've been pretty lucky. NASA's given us the chance to build the foundation model for the sun last year, and we built a model harness, which is the engineering methodology that allows us to test lots of different potential training regimes, but also because of our colleagues at Google, we were able to use TPUs. TPUs are much more efficient than GPUs for building foundation models. And I'm surprised this hasn't really made it into the zeitgeist because, obviously all the hype's about GPUs, but TPUs are really good for this. And we were lucky enough to work with, we'll use Google's TPUs last year. And so we believe that for the sort of scale that FDL works at, we can definitely build a precursor foundation model for the moon using TPUs and using this model harness that we've already developed. And so that's sort of the kind of ingredients we're bringing to the discussion. And then I know that Danielle and Anna Maria and others have got good opinions about this. And so really I'm going to sort of stop and sort of let you guys jump in. But really the kind of the message from us is we like to revisit this idea that it's possible to see thermal anomalies using machine learning. But what else could we start to identify? What else could we characterize? What could we do if we built a precursor foundation model for surface feature detection, and how might we go about it? So with that, and hopefully this isn't throwing you in the deep end, Ben, perhaps I'd get you to take the microphone and then sort of at the end of this, I can show you the eye candy about our kind of future facing vision that we have.
And Ben, why don't you tell us, I know James did a little intro, but tell us in your words a little bit about what you do and where you're at.
Yeah, thanks a lot for the introduction, James. I mean, first of all, I'm really excited to hear that we're having another lunar project this year. It's really great to have LSA's support and funding. And yeah, it really is building on a massive legacy of 4 or 5 years of work that we've done in the past with FDL. And yeah, I mean, looking back, we've had some really amazing impact. I think the one that sticks out in my mind is our work on permanently shadowed regions. And so we developed an algorithm called Horus, which can take a very noisy image of a shadowed region on the surface and remove a lot of that noise in the image and start to reveal kind of craters and boulders and other geological features inside of permanently shadowed regions. And so that was one of the great things about that work is NASA really liked it, and the Viper rover, which has been planned for a long time, that we gave some of those denoised images to the rover team and really helped de-risk their science targets and their traverse planning of that rover. So yeah, a bit about me. I was a PhD student at Oxford. Then I did a postdoc at ETH Zurich, and now I'm a lecturer at Imperial in the Earth Science and Engineering department. And we do a lot of work on planetary science as well. It's still a big part of my research, and so I'm very excited to be part of this FDL program and to continue helping. So maybe I can just say one thing about the future project that we've been discussing. I think this is not set in stone yet. I think hopefully James agrees.
Yes.
But I totally think this is a big, I mean, the bold vision here would be to look at foundation models seriously for the moon. And I think there is so much lunar data and so many different instruments and sensors that it really makes sense to try and train such a large model that is not just good at doing a specific task, say, for example, crater detection or denoising of shadowed images, but it's like a base model that can be pre-trained across many different tasks. And I think coupling that with unsupervised learning could be really powerful. I think what we've realized in the last 4 or 5 projects is that the real challenge with the moon is that we don't have many labels. And so we don't know what the ground truth is, and we kind of bias our algorithms to our labels that we provide. Whereas actually there's a lot still to discover, and so I think at a very high level that would be a great goal to aim towards. I can obviously go into more detail as well in specific techniques that we're thinking of, and but yeah, I think that's what I would say so far. How's that, James?
That's awesome. I was sort of going to put Daniel on the spot because I know you've run with this and extended on it, and it would be cool to hear a little bit about what you've been doing, and then to tee Anna Maria up again. Sorry to put you on the spot. I'd just love to hear what you're also thinking about, and I'm sort of hoping that we can, sort of between the people on this call, we can sort of start to concoct a sort of vision of what we could do if we started building a foundation model. And then if we get stuck, I'll show you the eye candy, but I don't think we're going to get stuck. So I'm going to give the mic to Daniel and then Anna Maria.
Well, I actually just came to listen, but if you put me on the spot, so yeah, one project that I'm currently working on also with Valentin and with Adam Lesnikowski, which is also an FDL alumnus, and it's a bit of a project idea that we actually had during FDL 2018 or 19 in the Starbucks in Mountain View, where so many ideas happened, well, between the Starbucks and the beach volleyball court, I guess. And so the idea was we have all these, or a bunch of human, as we call them, techno-signatures on the moon. So all these stages that were dropped there, or the Apollo landers and unmanned missions. And the basic idea was really to run a super unsupervised algorithm to see if it can identify these human assets, and then if it finds these, does it find anything else and what? So it was a bit driven, if you sit at the SETI Institute for 8 weeks, you get these crazy ideas, and the main idea was in the beginning, to find crashed UFOs or secret Nazi bases or obelisks or whatever people thought could be on the moon. But it turns out the algorithm also finds all, because it's agnostic, it really finds all other sorts of, cave entrances, rock falls, irregular Mare pitches. So it's really like a first order scan or skim of, skimming up the cream of what is there. And then there's still a lot to do, maybe with supervised missions to really, methods to really see what you can do with, what you identified as anomalous, but there's a lot to do. And then this work actually also spun out a bit of a commercial application idea. So it's really in the beginning, but we got some money in Switzerland to really look into how these ideas might also be commercialized eventually. So this is where we at the moment. Yeah.
Did you find lava tubes?
Some of them too. Yeah. So these how you call them, when there are lava tubes and then they're like the windows, like I'm missing the word, when the top is falling down. So we found a bunch of them too. I'm not sure if they're new yet. So we haven't run the full scan yet. We're right in the middle of it, but so we also find these. I mean, if it's anomalous, we find it, right?
Because I know high latitude lava tubes could be really valuable, because we've talked about it before. And if that's a nice that even in itself, that's a cool thing to be able to think about. But yeah, I'd love to hear other people's thoughts. And Maria, had you teed up, perhaps you can jump in next.
Yeah. No, it's good to see everyone, actually. So when I saw the email from you, James, I was like, oh my gosh, we can really use this in our project right now. So George Mason University, we've been working for more than a year, I'd say a year and a half now, on agent-based models of human habitats and human settlements in space. And we actually started in a reverse. We actually started with a model of human habitats on Mars, and then we came closer to the moon. And we adapted that model to, we got a grant, and we adapted that model for the moon for basically for the Artemis program, right? And we are looking at human factors in space. And NASA has been looking for quite some time on the idea of human factors in space, but mostly on the psychology and physiology of astronauts, but not that much on the idea of the team science and how, or the complex system between humans and robots and shuttles and all the engineering that goes into these habitats and space settlements. If there will be any space settlements as they are envisioned right now. One for the south pole of the moon, right? And then the moon gateway, which will orbit elliptically around the moon. So we've been trying to model these, and especially the human environment interactions, right? And one of the snags that we've hit in our project was that when we wanted to use the GIS from the moon, and there are so many files that we could get from USGS, from NASA, so there is no shortage in terms of the images that we can get from the moon. But these images or these files do not have GPS coordinates. And for our agent-based model, is actually crucial to have GPS coordinates, and we didn't have enough time or manpower to actually work on this interface between the images of the moon and any kind of computational manipulation that we can have on those, so that we can transform them into usable GIS files. Because, and it makes sense, right? Because most of these images were taken by LRO or some other some other instruments, and they were taken with the purpose of analyzing the moon for geological purposes and to understand the planetary science behind it. But now, if we are going to have astronauts back on the surface of the moon, it's really crucial for us to be as accurate as possible into modeling their interaction with the surface of the moon, right? And and their navigation on the moon. And these are not trivial things. Actually, NASA has been invested through the NASA CLIPS program quite a bit into sending different types of instruments or sensors that are specifically designed for navigation. And a couple of them are going now with Firefly Aerospace, that is due to land on Sunday. A few of them will go with the Intuitive Machine Mission 2, which is due to launch tomorrow. And we'll see how that goes on the automated side. But if Artemis is going to go as originally planned or in some other shapes or forms, you will have at some point not just you'll have humans in orbit on the moon, you'll have humans on the surface on the moon, and you will have robots and automated rovers on the surface of the moon, and also perhaps some sort of infrastructure to be determined, whether that's going to be cable cars or some sort of trains or movable habitats and so on. So for us, it's really, and for all of these projects, it's really crucial to understand the surface of the moon from the navigational purposes and the human interaction with the surface purpose, right? And I can actually, I was looking now while James was talking, I was looking to see if we can, if I can pull up quickly something visual to show you. I actually couldn't find it very quickly. Actually our agent-based model doesn't have a really great GUI right now, so most of the engine is behind the scenes. But we are participating also in the C program. C program is headed by NASA, which they have a distributed multi-agent system, and each of the teams is contributing with one little piece into this multi-agent simulation. So you have teams that are simulating the astronaut movement, just that. You have another team that is simulating the habitat. You have another team that is simulating the waste management. Another team that is simulating the automated rover, or how they envision that to go on the moon. And us, we are simulating basically the human factors, human behavior, team science, and human environment interactions, right? And yeah, so when I saw the call for this project from James, I was like, oh gosh, if FDL could help us, and we can also contribute to this, if we can, to solve this problem of navigation on the surface, and basically taking moon images and transforming those into GIS usable files, that would be really great. So we can make this even more distributed and even better overall for a simulation of this kind. So yeah, thanks.
Yeah, thank you. I'd love to hear from others. Like I know David Chouvron's on the call, and Ignacio from Ames. I mean, I think from our perspective, we're obviously, like everybody, drinking at the fire hose of agentic opportunities. What I haven't seen yet, and we certainly haven't done it, is connect a foundation model to an agentic system. And that could be awesome. Like if essentially we're using the foundation model as a kind of information substrate for the agents to access for some of the decisions they're making. But I'd love to hear other people's thoughts, and David, I know this has been your career for a long time, and Ignacio, if you're there.
Hey, this is Ignacio. I can talk. Oh, David, if you want to go first.
I was just going to say, this whole problem about navigation and knowing exactly where you found anything, exploration mission, a crew doing something out on rover or in a suit, being able to definitively tell exactly where that was found and be able to trace that and record that, that navigation is extremely critical. James Cameron had come to our office, Advanced Development Office, following his deep ocean thermal vents cruise that he did, and we had an astrobiologist that was on board that ship, and so that was a big part of what he was talking about as far as the submersible and where it was and where everything that they saw was located. So definitely support that idea that would be a very good project.
And actually, yeah, I'd love Ignacio for you to jump in, but Anna Maria, if anyone's started thinking about foundation models and agents, it's you. Have you experimented with that?
Yes, I have. Actually, I have another student who is working on that. I do. We've been trying to connect natural language processing at large and agent-based modeling for quite some time now. And I do have a student who's actively looking into doing that. And we've seen two areas of research there. So one is with respect to, just like you were mentioning, can we use natural language processing to extract or large language models to extract, I'm a bit old-fashioned, so I keep the old name. To extract bits of critical information that we afterwards include those into the decision-making of the agents? Or is there, I've seen a recent paper, I think it was 2024, so recently published at the end of last year, so just a few months ago, so instead of having a NLP pipeline into ABM, they would have a system that would be completely integrated, right, between agent-based modeling and large language models, to the effect that you would have the everything from the procedures and the decision rules of the agents done by the large language model agent, right? So you'd have a large language model that would be an agent in and by itself. But I think it's still developing, this area of research. I've seen a few papers on this. For example, probably the easiest one is you can already use GPT systems to extract ODD protocols. So ODD protocols are critical into the design of agent-based modeling. And you can do that in an automated fashion now using GPT systems. But I guess probably the cherry on the cake would be this large, completely integrated large language model with an ABM, which is except for this one paper, I haven't seen anything substantial coming out of here. So I think it's still ripen for research right now. Yeah.
So
And
thank you.
Ignacio,
yeah.
I know James has called on you a couple of times. If you could tell us what your connection to FDL is and what you're doing these days, as well as provide your thoughts on this discussion so far, that would be great. It's good to hear your voice, my friend.
Yeah, thanks, Jonathan, and thanks, James. I was waiting for the others to provide their expertise, but I'm very glad that I was able to make it to this call, and I'm very glad to see that there's some efforts to continue the theme of Lunar for FDL. As Jonathan said, and it's good to see you. I've been involved. Basically, I started by the same time, but Ben and Valentin joined in 2019 with the first project regarding thermal anomalies. And part of that project was actually we had a similar idea, trying to bring in all the different stack of data sets that we have across multiple spacecrafts and across multiple sensors, and see if we could use some sort of unsupervised learning. Back then was using autoencoders to see if we can find some specific signals that may be correlated with metallic signatures, but obviously without the ground truth, right, from being there. It's hard to tell, but maybe in the future, right, we can actually correlate and get that ground truth. But I think the idea that you guys are proposing here, I think is great. I mean, we are at a point right now where, from one side, on the technology side, we see these rapid advancements in supervised learning, generative AI, these new transformer-based architectures that are very data hungry. Charisma, if you could mute yourself, thank you. And on the other side, and I'm glad, James, that you mentioned John's talk, because he put together a fantastic workshop last week at Ames on off-world resources, and he brought together the mining industry, the space industry, and one of the key messages there was like, hey, how can we bring in some of the resources and tools that the mining industry is using here on Earth to start looking onto the moon? Particularly, as Ana Maria said, we're starting to see, probably this month, we're going to see, well, next month, a couple of landings on the moon, right, from 2 machines, and the other one, as well as iSpace, I think it's going to land at some point this year. So hopefully this is the year where we can see, the first successful private landing and the first, the beginning of a new space economy around the moon, right? I'll be very curious to see where this goes, but I feel like we can definitely build upon all the excellent work that's been coming out of FDL. It's great that we could count still with Google Cloud and NVIDIA for training big large language models. And yeah, I'm excited to see how can I help in any way.
And tell us where you're at these days, Ignacio.
Oh yeah, so I've been at NASA Ames for the last 5.5 years. I'm currently a principal research engineer on the Intelligent Systems Division. I've been working on basically the intersection of AI, robotics, and autonomy on a number of different projects. This year, I've mostly been involved in a few projects regarding future design of spacecrafts and habitats for Mars, specifically looking at how would you design from data standpoint and anomaly detection standpoint systems that don't require direct communication with Earth, so that the crew can it can be sort of like self-sustained, and the crew can we can help the crew to diagnose and also troubleshoot specific anomalies that could happen on their systems. And also we've been doing some work on moon-related projects using different methods, for example, regarding like neural radiance methods, like neural radiance fields or Gaussian splatting for the moon, and help enhance some of the elevation maps that we currently have on the moon, specifically on the South Pole, in support of previously Viper, but now in support of Artemis missions and CLIPS missions as well.
Can everybody see the crater? Is that coming up for everyone?
Looking good, James.
So this is, again, I've promised some eye candy, and I'm slightly sort of sheepish showing this now, but it's a sort of future-facing, perhaps something to aspire to. It's actually at the end of the thermal anomaly paper, and what you're sort of going to look at is a sort of hypothesis we might have, excuse me, about being able to determine the difference between asteroid-deposited metallics and useful resources that have been ejected by the impactor. And there's a lot of squinting at this. What might not yet be possible, but what you're hopefully, is this playing okay? Is it too high bandwidth, or is it you can see it?
It is. No, it's a little jerky, but it's working. Thank you.
Yeah. So what you're sort of looking at here are clusters of probability. And so, as Ben said at the top of the call, we don't really know because we don't have the ground truth. But these are essentially kind of making a sort of hypothesis based on metallic anomalies versus magnetic anomalies. And that's sort of as far as we're going. And so it may be a little bit of a stretch to say that some of these are deposited from asteroids and some of these are ejected from the lunar surface. But again, it sort of makes for a nice sort of future-facing visual. But I'll sort of play it with that caveat. But you can see here, like, wouldn't it be awesome if our foundation model had enough multimodality where it could actually start to determine the difference between asteroid-deposited metallics, which are here represented by the blue, and subsurface resources that have been ejected by the debris field. Again, it's very hard to visualize. This crater is 30 miles wide. Obviously, these dots kind of like look like they might be a mile wide. These are sort of clusters of probability. But this is, again, just our sort of kind of inspiration, really, for the sort of thing that we might sort of explore this year. And so just wanted to throw that in the pot with all those caveats and just see if this sort of sparks any discussion. We should probably put a big health warning on this, but yeah, love to hear people's thoughts. Anna Maria's got her hand up.
Yeah, so ground truth validation has been an issue for us too, because we don't really have any past events where humans lived in space for a long period of time. right? So the way we got around, or we are getting around that problem is, I think David was mentioning, James Cameron, is by looking into other areas on Earth that we consider them extreme in that sense, right? So yes, we have some information from the ISS, but we also have information from how people live in the submarines, right? Navigation undersea and navigation on the moon, it's actually very similar in certain ways with respect to understanding the extreme environment. Because on the seafloor, and we've looked at that too, on the seafloor level, you don't really have, again, like you can't really use GPS, right? So you can only use echolocation. Going back to ground truthing and validation, we are using information from any kind of extreme environment that we could find in terms of case studies. So Antarctica is one, submarines is another one, oil rigs is another one, subsea environments, we only have one so far, but that can be another one. Yeah, the Arctic, so I mentioned that. So in terms of ground truthing for feature detection, again, maybe doing the same type of algorithm and looking into a similar environment that is on Earth might be a way to go around that. So
Nice. Yeah, agreed. Daniel, you put your hand up.
Yeah, it's more of a question for the hive mind here. So how do I phrase this diplomatically? So given the certain situation in the world, how long will that data still be available? Do people have an idea? I mean, could it be that next week Doge says this is private data and we have to pay for it?
Yeah, Daniel, that's a major issue for some of my students. So I have some students that right now are very avidly downloading data on their computers and on our server at the university, because we don't know if that's going to exist later on. So that is a very good question. Yeah.
As we said at the beginning, this is really a chance for all of you to participate in the FDL.ai network. So we'd love to hear from any of you who are joining us today who might have been doing work in these domains and thoughts on this. Please raise your hand if you'd like to jump in and join the conversation.
Thanks, Ben.
Yeah, thanks. Sorry, I have to leave now. But yeah, I really enjoyed this conversation. Yeah.
Thank you.
Thank you, Ben.
I guess a follow-up from what Anna Maria was saying, how about just locations on Earth where we could, although we have access to GPS, we just either ignore it or use it as a backup, like a ground truth sort of comparison, and just do some things in a terrestrial analog type site, and then develop the methods and be able to prove them with that technique. And Maria, do you think that would be a good approach?
Yeah, I mean, if we look at the subsea environment, a lot of it is still not mapped, right? There's still, yeah, I mean, you can compare a very well mapped of undersea with a not so well mapped environment undersea, and then compare that with the moon as well. So, yeah.
Excellent. Well, so Ben's left us, and the other part of this discussion was just doing a sort of high-level refresher on what FDL is. And I appreciate some of you know this already, but for those who are joining us for the first time, you might like to hear about how FDL works. Is that, Jonathan, is this a good time to transition?
Perfect. It is a great time to do that.
Just
please.
Sort of being aware of those segues.
Absolutely. And we hope everybody's getting a little sense of what we mean when we talk about this thing called the FDL.ai network. I'll stress again, this is 800 scientists. A handful of them are here today. Some of them who have been a part of this for 6 years now. And this community continues to grow. And the things that James is about to talk about really are present an opportunity for you to participate in this growing community of people doing this very exciting work. So yes, let's get into how it works and how people can be a part of it and join.
Yeah, it's interesting. I think, we've actually been partnered with the LSA for 8 years. But it's sort of interesting. This is sort of more of a red wine discussion. But the ML techniques for resources didn't really start coming online to 2018, 2019. So you're right to say that really the golden period was the last 6 years. And that's, because prior to that it was bootstrapping. We've had this really amazing run. And so this is absolutely something we want to build on, as I mentioned at the top of the call. The way it works is we really try and create sort of collective intelligence for the summer. FDL is a year-long process. It starts with challenge definition around this time of the year, which is sort of what we're doing at the moment. So he does define challenges, and then we go through to choosing the teams. We use the Hollywood model. So once we have the challenge, that's like the script, and then we pull the team together based on what the challenge requires. And then we're very lucky to have amazing partners like Google Cloud, NVIDIA, and others who provide the compute resources. And then we put the team together in the summer. That's where we really crunch the pipeline. And then in the fall, we do some further engineering, get it ready for open sourcing, write the papers, and then use the end of the year in Europe's and AGU as a sort of bookend. So the FDL cycle is a year. But of course, the pipeline building happens in the summer, and we take advantage of the academic calendar to pull the teams together. So that's really how FDL does what it does. This is sort of what like a typical timeline looks like over the summer. We have an on-ramp period where we start to kind of build the connectivity between the relationships. We really believe in the power of culture to do great work. And then we start exploring the area, so exploring the problem definition. We go through a development phase, calibration, improvement, and then we end up with a sort of showcase, which sort of is a chance to share the work to peers in the community. And then, as I mentioned, we use the fall period to refine that and write up the papers. And every year it seems to have worked. So that's the magic formula. We really, as I mentioned, really believe in culture, and we have a fantastic collaboration coach who, as I say, when you bring teams together who don't know each other, how do you make sure those teams can really become world class? And we spend a lot of time on this. And if you join FDL and the Lunarlab this year, certainly you'll be sort of invited to sort of take part in these sorts of ideas. We really believe that motivated teams can exceed the abilities of a lone genius. This is absolutely something we believe to the core. It means having curiosity, compassion, courage, and also seeing things with a smile.
And James, I'll say that even beyond believing it, we've experienced it over and over and over again. It's real, it's happening. And I think today is one of the evidences of that. We have people from all over the world in academia and space agencies who are here on this call today that are demonstrating just how true that is.
Yeah, I mean, we probably need a glass of red wine or something, but I sort of believe that there's a sort of vibration state that you get to when everybody's in sync. And then once that happens, everybody starts to kind of contribute, and suddenly everybody gets better. And then once that happens, you can do amazing things. And so that's sort of the culture that we try and create. So if you're interested, please do apply. Applications are open. Please forward this to people that you think might be interested. And at Lunarlab.ai apply, or FDL.ai. Application is going to close on the 31st of March. And if people are interested in the sister programs, you may have noticed that we're sort of creating sort of sub brands: Lunarlab, Heliolab, Earth System Labs, and this is really to a sort of shift from sort of being about one data set to one model to one result. We're now trying to create orchestrated systems, and this means sort of building an AI infrastructure. And so we're starting to notice that we're having quite unique infrastructure for the different labs, so to speak. So there's our sort of lunar portfolio, and there's our Helio portfolio, and there's our Earth Sites portfolio. And so to sort of reflect that, we're starting to sort of create these sort of sub functions. And that's essentially, if you're paying close attention, that's why that's happened. But this is still the same old FDL, the same culture and the same way of doing things. We've just organized it with these sub brands. Again, if you're new to FDL, it's a PhD postdoc level thing. That's sort of the sweet spot. Of course, we are really open to people at any point in your career. So David, if you felt like giving it a go, we'd be happy to have you. And so you know, and of course, researchers get a stipend, and it's full time for the 8 weeks between mid-June and mid-August. So that's really the summary. All this information is online on FDL.ai. And with that, that's our show. If there's any questions.
Yeah, let's do a little Q&A. Let's see if anybody has any questions before we begin to wrap up here. Raise your hand and let us know. We'll call on you, and or maybe you have some comments that you'd like to share. Please participate. Oh, Olga. Olga, by the way, as you probably know, we're doing the heliophysics Heliolab info tomorrow. Hello,
Yes,
Olga.
can you hear me?
We can. Please.
Yes, very good. I sign up for tomorrow also, but I'm wondering at a comment, because I don't know what's going to happen tomorrow, if Moon program, Lunarlab, going to include safety environment for a mission, or for humans, for instruments from coronal mass ejection or solar energetic particles, or is this question belong to Heliolab? Because if you go to the moon does not have magnetosphere. It's nothing going to prevent from harmful radiation, and we have to be able to predict when we have to say, okay, now you hide, or now you go to the safe mode, or just don't go at all. Is it part of your program? Because we are, and I represent Advanced Heliophysics from LA, and we are incorporating AI in our solar studies. And in the same way, we can include our moon on our pathway. Or we can suggest to include it in your work with younger scientists. Thank you.
Yeah, so we have a pipeline that can predict solar energetic particles on the lunar surface. And so that was actually supported by Lika Guhathakurta from NASA SMD. And so we were really proud of that work. It's the first time it's been done. And the paper actually the technical memo will be available in the next couple of days. We're just waiting for sign off. And so that'll be available on Heliolab.ai. So yes, the answer is yes. We know about the problem, and we really believe in solving it. And as far as I know, this is state of the art for radiation prediction on the lunar surface. The Lunarlab, I guess, inherits that work because that was funded by the heliophysics division. But the pipeline that was developed, it's ground truthed using lunar data, but actually the methodology would be applicable to the whole solar system. But yeah, it's as I say, if you check out Lunarlab.ai in the next couple of days, or even tomorrow, I think that'll be up. But yes, as I say, Lunarlab benefits from that work.
Okay.
And we hope you'll join us tomorrow, Olga, as a matter of fact, as we
absolutely.
dive into it.
Yes, thank you.
Great. Thank you. Anyone else?
David.
Any other questions? We want to be sure we give everyone a chance to. Oh, David, I see your hand up. Yeah.
Yeah, so one thing I was wondering is, so far, I think FDL has mostly been dealing with science applications for AI in space, and I'm wondering if there's any consideration for engineering applications, generative design for facilities, support for keeping things functioning, for figuring out when processes starting to be done, like ISRU process equipment, solving the kinds of problems that in the past, I think we've generally always said, hey, that's something that only the human can do. And it's really looking like with advances in AI, some of that could actually be shifted more to AI and robotics. So I know that's a little different than anything I've seen before, but the engineering applications of AI, I think, would be very interesting as well.
I'll let Anna Maria jump in on this, but I can say that we've put our toe in the water with agentic systems, and I've seen the light. And I think it's going to be enormous, really, for so many of those things. But it's interesting because, agent systems still need to have like a world model that they can access, and so that discussion that we were chatting about could an agentic system access a foundation model, that feels like an open thing for us to try and do. And Anna Maria is nodding, so that I'm relieved.
No, absolutely. I mean, I think that's for those who are not familiar with agent-based models, I always say that the strength of agent-based models comes from the idea of interactions and from the fact that you don't necessarily need a lot of data to have a good model. They come, they are a technique mostly used for complex systems, and used for complex systems where you have a lot of heterogeneity, where you have different agents with different type of decision making. These agents can be humans, they can be animals, they can be institutions, they can be countries. So any type of decision making or agent, and they can interact among themselves and with an environment, and then you observe emergent phenomena, right? What comes out of it. And the way we are, or the input, the way we are informing these models, yes, sometimes it's data, but and the data doesn't necessarily have to be quantitative. You can also inform them with qualitative data. So that's why this idea of using output from text or from images or any kind of multimodal data can also be very, very nicely bridged with agent-based models. Again, like the difference is that, yes, you can also have machine learning agents, machine learning engines underneath an agent-based model, but you don't necessarily have to do that, right? While for machine learning models, you really need a lot of data and good data so that you can have good models there. So I think bridging them together, it's where the power is. The output of an agent-based model can always be interpreted as also by qualitative observations and quantitative observations. So you can validate it with other existing data or with case studies, and after that you can design all sorts of scenarios. Which have not been done before. So if you want, again, like to predict how humans are going to live on Mars, right? Something that has never been done before. If you have a very well-informed model in terms of again, the agent decision and how they would interact with the environment, how they would interact with each other, then you might get to very closer to a pretty good idea about how the system is going to look like in the future. So I hope this explains a bit. Yeah, and again, the power comes because they can model complex systems where you have ecosystems, you can have so it's no virtual reality, because sometimes I get this question, are agent-based models, oh, that's like virtual reality. Not exactly, because you don't, the power there comes again from the way these agents interact with each other and with a certain environment, and you can have a list of parameters, and by tweaking those parameters and the initial conditions, you can have different outcomes. And if you are searching for a particular outcome, you can then trace it back to which set of parameters and set of initial conditions led to that, right? So yeah.
I think, David, the answer is we see the light.
Yeah, one area I've talked with Dan Rasky about on a few occasions is the idea of maybe using AI to help with making better trade studies in the engineering design and systems engineering process. Doing a better job of coming up with what are the options, how do you rate the merits, the figures of merits for each of the different options, try to avoid something being excluded because well, maybe there was a hidden agenda that kind of kept that one from emerging.
If Dan wants to help us do a heat shield, we should talk.
Yeah, that would be a good one. Charlie Camard would probably help on that too. You know, Charlie.
Boy, add Dennis Wingo to the mix, and we got the whole gang.
Yeah.
No, I think it's interesting because, you know, we did work on the What's on the Moon challenge, which was the figuring out how to create electrical infrastructure on the lunar surface. And the solution we came up with was a microgrid that was delivered by robots. And lots of different solutions, but that was the one we were interested in. But what we were thinking about was each node could have a certain amount of intelligence. Now, it's interesting, as soon as you start thinking about an agentic system managing that service, you suddenly have a big inference problem. And one of the problems we've struck with terrestrial systems is if you have 1 or 2 or 3 or 5 agents, suddenly the inference cost goes up enormously. And instead of waiting for a second for your result, you're waiting for minutes. And so suddenly it's like, well, wait a second, we're going to have 12 agents informing a complex system on the lunar surface. What's the compute environment that's going to allow that to happen? That this hasn't been solved. And so I think in the very least, it would be worthwhile spending some time thinking about some of those use cases and what's the compute infrastructure that we'd need, not just GPUs, but the full gamut of compute for those sorts of complex agentic systems.
Yeah,
excellent. Thank you, David.
Yeah, one of the things that we had talked about, Dan, and if you remember Anita Gale by chance, Anita had the space settlement design competition that she did. We were looking at seeing how AI could be used to come up with a design to solve the RFP that Anita puts out in her weekend-long program for high school students, and using that as kind of a case study. And so I'd been doing a little bit of experimentation with how well large language models were capable of coming up with solutions to the RFP that Anita had put out on the last, probably the last 2 or 3 that she did, and one since she's passed away. But that could be an interesting way of doing the study too, to see what all it takes to put the whole proposal together for a lunar base, and what you would include in it, what sequence of construction you would want to do, what do you got to get there first, how much power, how much storage, those kinds of technical issues. So many possibilities and opportunities for us to pursue. James, I just want to say that we have about a minute left to be at the top of the hour.
That doesn't mean we have to stop now, because you might want to keep going, but we do want to be respectful of people's time. And we want to remind them, where do they go if they want to apply or learn more about the FDL network and specifically Lunarlab?
I think that was it. Or is there
Yeah.
anything else that people? Otherwise, it's
Where do they go?
FDL.ai.
That's it.
FDL.ai.
FDL.ai.